Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video. And in fact, it's another video series for the week. We started last week with quadratic expressions, how to factor, I forget all, combining like terms, distribute, things like that. Now we're going to solve quadratic equations, and I hope that you know how to do the things that we did in the past week, specifically regarding factoring. You're going to learn some new stuff here. It's going to be a little bit different, but we're going to be solving quadratic equations for this week. I'm going to have 4 videos in this series. The first one is going to be on solving by factoring, so you got to know how to factor. And the next 2 are kind of tied together, solving using square roots and something called completing the square. Again, they're kind of tied together, but they are 2 separate videos. And then I'll have a last one solving using the quadratic formula. So again, 4 videos in total. I hope they'll go relatively fast, but they take some time to really master. You can probably, easy to learn, hard to master kind of thing. So I'm just going to jump right to it right now. Let's go ahead and look at solving quadratic equations by factoring. And in order to do it, you're going to have to understand this property here. I'll tell you it in a moment, but let me start with this idea. Okay, if I were to solve this equation right here for x, we could easily do it by getting the x term by itself. I add 6 to both sides, and then I divide both sides by 2, and I get my answer. Now, if you have a quadratic equation with both a quadratic term and a linear term, something like this instead, okay, it's not the same. You can't get x by itself the same way as you could in the other one. See, if I add 4 to both sides, now what do? I have x's in 2 separate terms. These terms can't combine. I can't just move this x term over because I can't use x in my answer when I'm solving for x. It's like using a word you're defining in its definition. We can't do it that way. We sort of can, and you're going to learn it later here, but we're going to have another way of learning how to solve this way, and it has to do with factoring and a specific property. So instead of trying to get x by itself like that, we're going to do something with the factoring here. So here it is. It's called the zero product property. And let's make sense of this thing. It's going to totally make sense to you. It says if a times b equals 0, then a equals 0 or b equals 0. What this says and what this means is, if I multiply 2 numbers, 2 mysterious unknown numbers, and my result is 0, then one of those numbers got to be 0. That's what it's telling you, right? This comes kind of twofold. Think of it this way. Number one, you can't multiply 2 non-zero numbers to get 0. One of them has to be 0, right? You can't multiply 2 non-zero numbers. So this is really special with 0. I can't say 1 times -1 is 0. That's not true. No fraction, whatever. One of them has to be 0. And that's the other portion of this that makes this twofold. Only as long as one of the numbers is 0, then the whole result is 0, right? You don't need both numbers to be 0, just one of them. 10 times 0 is 0, but 0 times 0 is 0, and 1,000 times 0 is 0. But one of them has to be 0, and only one of them needs to be 0. So let's look back at that one more time. If a times b equals 0, then it's true that one of these 2 numbers has to be 0, and only one needs to be for this to work. And this big word or really comes into play. It's not and. Only one of them needs to be. So this is why it's called the zero product property. It's a product. You're multiplying 2 numbers, and it equals 0 in the end, and that's the property that they're telling you. So let's look at how that works here. What does that have to do with our quadratic equations and solving them? Well, if a quadratic polynomial can be factored, this includes getting a greatest common factor, and that factorization can be set equal to 0, then the individual quantities, the ones when we factor, when we get it into this form, the individual quantities can each be set equal to 0. And easily solvable as a linear equation. So let's say that we're going to do it right here in a second, but this can be your A and this can be your B. If A times B equals 0, then either A equals 0 or B equals 0. And let's jump into it right now. We're going to look at this problem here. This one's already factored for you. You don't want to distribute. You are halfway home here. If f plus 3 times f minus 9 equals 0, remember, this is like your A and your B. These are quantities that are multiplied, and that's okay. We can set it that way. If f plus 3 times f minus 9 equals 0, then either f plus 3 equals 0 or f minus 9 equals 0. Now, we didn't solve for f yet, but we are just one step away in both of these little equations to solve. But see how we split that up? We're using this property, the idea that 2 things are multiplying to be 0, and say for this to be true, one of the quantities, not f, one of the quantities has to equal 0. Absolutely. So what's f going to be? You subtract 3 from both sides, you get f equals negative 3. That's one of your answers. And you add 9 to both sides, you get f equals positive 9. That's one of your answers. Let's double check. I'm not going to double check each time, but let's check that out, make sure that works. Try and plug in negative 3 into this and see if this works. Negative 3 plus 3 times the quantity negative 3 minus 9. Negative 3 plus 3 is 0. Negative 3 minus 9, well, that's negative 12. But who cares? What's 0 times negative 12? It's 0. 9. 9 plus 3 is 12. Uh-oh. 9 minus 9 is 0. Oh, phew. 12 times 0 is 0. So see, only one of them has to be 0 to work, and this is where you're seeing more than one answer. See, in linear equations, there's only one possible solution, or none. You might get an infinite set. We're not really referring to that. Quadratics, you're going to see a lot of two-answer sets, more than one answer in these things here. All right, let's take a look at the second one. And the second one is arguably easier, but because it doesn't have the set of two parentheses, sometimes it bothers people. Q times Q plus 5 equals 0. Look, Q is like your A and Q plus 5 is like your B. This is multiplying two things. If it makes you feel any better, you can wrap this around parentheses as well. Point is you're multiplying two things to make 0. Again, it bothers some people that it looks a little bit different, but this says either Q equals 0, which, hey, that's just your answer straight up, or Q plus 5 equals 0. And if you subtract 5 from both sides, you get Q equals negative 5. So Q equals negative 5 or Q equals 0. Don't forget that Q on the outside counts as one of the things. 0 times, if you plug in 0 here, 0 times 5 still equals 0. Right, that works. Now, you might have seen in these two problems here so far, you see this was f plus 3, the answer was f is negative 3. And this says f minus 9, and the answer was positive 9. And this was Q plus 5, the answer Q equals negative 5. You might say, isn't it just the opposite of the number there? Sort of. As long as this coefficient's a 1, yeah, you just switch it. You know, this is f minus 9, the answer is going to be positive 9. You just switch it. But you're going to run into a problem like this one right here where you can't just switch it because you got to make sure that you're seeing there's now a 4 coefficient in front of my k and a 2 coefficient in front of my k. A little bit more to here. All right, but they are equal to 0 here, so let's go ahead and solve it. 4k plus 1 equals 0, or 2k minus 7 equals 0. Hopefully you're feeling comfortable about this idea of zero product property. I'm setting both quantities equal to 0 and solving for k within. I'm going to subtract 1 from both sides here, and then I'm going to divide both sides by 4. That's negative 1/4 I need. And then on the other one, so that's my answer for one of them. On the other one, I'm going to add 7 to both sides, and then I'm going to divide both sides by 2. So I get 7 halves right there. Just leave it as a fraction. Try not get decimals for that one unless it was something else. Just we're good. Those are the two answers for that one. Again, it wasn't just negative 1 and positive 7 because I had to divide by 4 and I had to divide by 2. So a little more work on that one, and there's that. All right, but those ones were already factored for you, and that's nice. That's good. You might not even know these were quadratics, but use the zero product property. So I got this one right here. This v squared minus 23v equals 0, and I need to solve for v. Well, it's the same thing as these ones here. This is a quadratic function, and I'm going to factor it. I'm going to factor it. There's a common factor. Remember, this includes GCFs. Common factor of v. Let's factor it out, and I get v minus 23 inside equals 0. Again, I just told you, in order to solve these, you got to know how to factor. So if you don't know how to, find my video that says something like factoring quadratic polynomials or something like that. That'll help you. So now I use the zero product property from here. Either v equals 0, which is one of my answers, or if you were paying attention last time, if v minus 23 equals 0, v equals 23. Remember, it's the opposite of that other thing. Maybe you're going to catch on with that pretty fast. I want to make this video fast, and those are your two answers. Now, this one's probably harder to double check in because you got to do this whole, well, 0's easy. 0 squared is 0 minus 23 times 0. That equals 0. 0 minus 0 equals 0. 23 squared, I can't tell you at the top of my head. 529 maybe? I don't know. 529 minus 520. It's something like that. If you plug them in, it should work out. But those are the only two answers, but they both work. There's more than one answer for these. All right, this next one here, this is a more basic, or not basic as in easier, but it's more standard form of what you see when it comes to factoring quadratics here. Quadratic coefficient of 1. I got to find out what two numbers multiply to make 24 and add to make negative 2. Okay? Negative 12 plus 2, no. Negative 8 plus 3, no. Negative 6 and 4. Negative 6 times 4 is negative 24. And I was playing a fool for you guys. I knew it. Especially when I made the problem. Negative 6 times 4 is negative 24. Negative 6 plus 4 is negative 2. And if you recall, you put these in afterward. I really got to put this on the side to fit everything. So z minus 6 times z plus 4 equals 0. Now that I'm factored, I'm going to use zero product property to solve. Pretty standard the rest of the way. Again, it's going to be the opposite of these two. That's a z, I'm sorry. Z equals 6 and z equals negative 4. Again, only because that z is a linear, the linear coefficient's a 1. I just got to add it over and all that stuff. All right, this one's going to be a little more work here. Now, a couple things to this problem. You might notice that, hey, you have a greatest common factor here of 4w. All right, let's take a 4w out of this thing, and then instead I have I have w plus 2 equals negative 3. Here's the thing. You have to remember what our property is called. It's called the zero product property, okay? This is when you have a product that multiplies and equals 0. This right here, I'm multiplying two things, 4w and w plus 2, and equals negative 3. There's no negative 3 product property. It's not true that if I multiply an a times b, it's negative 3, that either a or b has to be negative 3. That's definitely not true. I can find two other numbers to multiply. You know, I can multiply negative 1 times 3 and I can get negative 3. Furthermore, if one of my numbers is negative 3, that doesn't mean my result's negative 3. 0 is special. 0 is special, and with that 0 being there, it's required that that factorization is set equal to 0 for you to use the property. So I can't just factor 4w out of this, set these two equal to negative 3, and call it a day to solve for w. I got to set this equal to 0 first, and then I got to factor from there. So to set it equal to 0, I'm going to add 3 to both sides here. And this is the last problem. And now I got to factor from here, and this is where, you know, there's no common factor anymore, so you got to try a little harder with this one. I'm going to try and do it really fast here. It's either 4w and 1 with the 3 and 1. No, that's not it. It's going to be 2w. It's going to be 2w, 2w, and one of these has to be a plus 3 and a plus 1, like that. 4w squared plus 2w plus 6w is 8w plus 3. Boom. So that's what it factors down to, and it's not just w equals negative 3, w equals negative 1. Remember, at this time, it's probably best to actually set these two equal to 0 so you can solve it from there. You got to do subtraction and division. You're only 2 steps away for each one. Subtract 3 from both sides, divide by 2 from both sides, and I get negative 3 halves. And then here, subtract 1 from both sides and divide by 2 from both sides, and I get negative 1 half with my face in the way, I'm sorry. And that is your final answer there. All right, so that's how you solve by factoring. Now remember, it has to be factorable for it to work. And if it's already factored, you're halfway. You're probably more than halfway there. But don't distribute after that. You're on your way to it if it's already set equal to 0. All right, so that ought to do it for this one, guys. This is Mr. Robinson. That's how you solve equations by factoring with quadratic equations by factoring. Next one coming up is solving using square roots. Take care.